So here we will start to look at carboxylic acids and nitriles. Now, in this section, when it comes to carboxylic acids, we're mainly going to be focusing on nomenclature as well as properties. The reactions of carboxylic acids fall under the category of nucleophilic acyl substitution, and that's actually the next major section in this course. And so for most reactions of carboxylic acids, we'll cover those alongside with esters and amides and anhydrides and acid chlorides because the mechanisms there are so similar. But we will here start with some nomenclature. And nomenclature for most carboxylic acids is pretty straightforward. In fact, I would say similar to aldehydes, it's definitely one of the easier functional groups to do. And the reason for that is, if you recall with aldehydes, one of the more annoying pieces that we have to deal with in nomenclature is figuring out which end of the chain to number from. And with an aldehyde, it was always easy because we knew that the carbonyl carbon of the aldehyde was always carbon number 1. The same thing is true for carboxylic acids. So here's a 5-carbon carboxylic acid. We know once we would get into any substituents that the carbonyl carbon is always going to be carbon number 1. And so that means that just like with an aldehyde, we don't need a number to indicate where the functional group is. All we need is the proper ending to show what functional group we have. And so the ending for a carboxylic acid, this molecule is 5 carbons, which we know is pentane. In order to show that it's a carboxylic acid, we remove the E here and add oic acid to it. So this would be pentanoic acid. You know, otherwise, until we get into diacids or some important common names, there's nothing new or unusual about the nomenclature for carboxylic acids from what we learned for aldehydes. So basically take everything that you learned for aldehydes, and instead of Al for an aldehyde, you use oic acid. Now, the one thing that does make carboxylic acid nomenclature a bit more annoying than other functional groups is the abundance of common names. And there's no getting around it. There's just a ton of them. Some are important for this course, some more important for other courses, especially for those who are going to take biochemistry in the future. You'll see a ton of these in the future, but we're going to talk about some of the important ones here. So carboxylic acid that has just one carbon, derived from methane, our initial instinct might be methanoic acid. But this is more commonly known by its common name of formic acid. Two-carbon carboxylic acid, generally not referred to as ethanoic acid, but by its common name of acetic acid, which we find in vinegar. This one we may be familiar with from lab already, because we've used on previous occasions benzoic acid. If you add a second carboxylic acid to that aromatic ring, right next to the first one, this is something that we are using in our luminol lab. This is phthalic acid. And then we have a 4-carbon carboxylic acid, which is more commonly known as butyric acid. And butyric acid is a compound you might recognize, as it is what's responsible for the odor you get when butter goes bad. So again, the nomenclature for carboxylic acids, as we can see, relatively straightforward. However, what's the most common place that we find carboxylic acids? The most common place that we find carboxylic acids is that they're very abundant as fats and oils. And it's, the carboxylic acids we find in these situations aren't terribly complicated. They're almost always straight chains. With some number of carbons. The one thing that can vary is sometimes there will be some alkenes in them. Those are what we call unsaturated fatty acids. But the issue is, because these are such common biological compounds, this is where we have even more common names. So what we'll do here is we'll list the common name, the IUPAC name, the melting point, the number of carbons, the number of CH2s. So the total number of carbons would be 2 more than this N. And then where do we find these? So when we talk about fatty acids, they typically don't start up until around 8 carbons. And you'll notice that all of these are even numbers. So octanoic acid would be an 8-carbon total molecule, which means that this N here would be 6 CH2s. It has a fairly low melting point. 16 degrees Celsius means it's a liquid at room temperature. More commonly, though, this is, at least in that context, referred to as caprylic acid. And the primary source of caprylic acid is from milk. If we go up 2 carbons, and that's what we're going to do here, is 2 carbons at a time, we get to capric acid. Its IUPAC name is decanoic acid. As our chain gets longer, our van der Waals attraction increases. And so the larger or longer our fatty acid is, it's going to go from liquid to solid. Capric acid, also commonly found in milk, as well as coconut oil. And I shouldn't say that these are the only source. These are just one of the most common sources for each of these. Okay, 12 carbons, we have lauric acid. Systematically would be known as dodecanoic acid. Again, chain's getting longer, boiling point goes up. And lauric acid, again, commonly found in milk, as well as coconut oil. And lauric acid is used actually fairly extensively in soaps. At 14 carbons, we have myristic acid. Myristic acid most commonly found in nutmeg. Then we could certainly say that some of the next ones are some of our most common, our 2 most common. And that's palmitic acid, We're not even going to list the source because it's found just about anywhere that you run into fats. This is 16 carbons. Again, slightly higher melting point. But palmitic, as well as the next one at 18 carbons, steric, these are very commonly found in things like olive oil and other cooking oils. And as we said, these are the two most common saturated fats that we have. And finally, these do keep going, but once you get above 20 carbons, they start to become much less common. Arachidic acid, its systematic name, eicosanoic acid. Most commonly found in corn and peanut oils.